Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum and welcome back to another video. So today in this video we'll be discussing Cambridge O level physics paper 1 multiple choice question. The paper is May June 2021 5054 paper 1 variant 2. So let's get right into it. So question number 1. A student determines the circumference of a ball. So first of all, whenever you read a question, first of all you need to understand that what kind of shape will it be, what is the circumference. So the circumference is the outer boundary, and he needs to determine the circumference of this football. So which instruments gives a reading that is the circumference of the football. So can he use a caliper? No, he cannot. Why? He cannot use a caliper. Why? Because caliper can't measure the circumference. Micrometer cannot. A ruler cannot, because a ruler is straight like this. A ruler can never measure circular things, right? So tape is the best answer. So our answer is D. Now let's move on to question number 2. A coin falls from rest. So from rest, which means its velocity was zero, its resultant force was zero. So this is some information that they have given us through the air and eventually reaches a constant speed. So when is the constant speed reached? At constant speed, it means terminal velocity is achieved. Why? Because at terminal velocity the speed is constant and there is no resultant force acting on it. So F is zero and the speed is constant and terminal velocity is reached. There is a resultant force acting on the coin due to the two forces P and Q shown in the diagram. So the two forces acting are before the object reaches terminal velocity. Once the object reaches terminal velocity, although forces will be acting, but there will be no net force once it reaches terminal velocity. So now let's look at what the question is saying. What happens to force P, this force, and what happens to the resultant force before the coin reaches constant speed? So a coin is being dropped, has been dropped, right? A coin has been dropped from rest. It is moving. So the upward force acting against it, what will it be? It will be air resistance. So the force P will be air resistance, and Q will probably be its weight, right? Now they're asking, okay, what happens to the force P and what happens to the resultant force before the coin reaches constant speed? So as I told you, uh, at constant speed there's no net force, which means there's no resultant force. The F is equals to zero, so F will decrease, right? Now these two options are eliminated. Why? Because they both say that resultant force increases, so resultant force will decrease. And what will happen to force P? Since the object is falling down, its speed is increasing, which means its air resistance will also increase. Hence force P will also increase. Hence your answer will be increase decrease. Your answer will be C. Now, next question, moving on to the next question. The diagram shows the forces acting on four identical solid blocks. Each arrow represents a force of 20 Newton, which means this is 20 Newton, this is 20 Newton, this is 20 Newton. So each arrow represents 20 Newton of force. So yeah, which blocks are in equilibrium? So for equilibrium, we have studied two conditions, right? We have studied two conditions, that there should be no resultant force acting on the object, no resultant no resultant force acting on the object, and the object should be in equilibrium. Means its moment should be in equilibrium. What does it mean? That sum of clockwise moment is equals to sum of anti-clockwise moment, right? These are the two conditions of equilibrium. Now let's look at the question again. They're asking for you which of these four blocks are in equilibrium, which of them, right? So is P in equilibrium? 20 Newton acting here, 20 Newton acting here. So is P in equilibrium? Yes. Why? Because the forces are equal and in the opposite direction, which is why P is in equilibrium. So P is correct. P is the correct answer. Now 20 Newton here, 20 Newton here. So is this object in equilibrium? No, this will not be in equilibrium. Why? Because they're not equal in opposite direction, right? So if this pushes over here, if this force acts over here, this opposite force should act over here for it to be in equilibrium, but instead it is acting downward, which is why this Q object is not in equilibrium. Now let's look at R. 20 Newton upwards, 20 Newton downwards. Pretty simple. This is in equilibrium. Now 20 Newton downwards, 20 Newton downwards. So total of 40 Newton acting downwards. So how is it in equilibrium? It is not. Hence your answer will be P and R only. A. Right? Now let's move on to the next question. A student lists three changes that affect the stopping distance of a car. Right? Increasing the braking force. So he listed three which affect the stopping distance. Increasing the braking force obviously will decrease the stopping distance. Increasing the friction between tires and road. More friction means that the car will stop more quickly. Right? Increasing the speed of the car, if the speed increases obviously the braking distance will increase, which change or changes increase the stopping distance. So what does okay, let's learn first what is the stopping distance. So the stopping distance is the time taken for car to stop or to come to rest when its velocity is zero. So once you apply the brakes until the car's velocity becomes zero or it comes to rest, that is a stopping distance, right? Stopping distance also includes, okay, I'm sorry, I didn't tell you this. Stopping distance, this is the braking distance, and the stopping distance includes thinking distance as well as braking distance. So there are three types of distances: thinking distance, braking distance, and the combination of both of these is the stopping distance, right? So remember, they frequently ask questions like these, right? So if you increase the braking force, the stopping distance will decrease, so this can't increase the stopping distance. Increasing the friction between tires and the road, if the friction increases obviously the car will come to rest earlier, so this won't increase the stopping distance. Increasing the speed of the car, yes, if the speed of the car increases it will take more time to stop, hence the stopping distance will increase. So our correct answer or option is D, which is 3. The diagram shows a satellite orbiting a planet at a steady speed, not a steady velocity. Remember, because velocity is a vector quantity. So it is orbiting at a steady speed. In which direction does the resultant force act on the satellite? So the resultant force, always remember, for objects in a circular path, right? Like it's orbiting like this, right? So objects always in a circular path, their their resultant force always acts towards the center. So since it is over here right now, its resultant force will be A. Now let's move on to the next question. Question number 6. The gravitational field strength in space is smaller than the gravitational field strength in space is smaller than on Earth's surface, right? Because on Earth's surface the gravitational field strength is 9.81 Newton per kg. So as you move away from Earth, obviously the gravitational field strength will decrease. A rocket is used to launch a satellite from Earth's surface into space. How are the mass and the weight of the satellite affected as the satellite moves away from the surface of Earth and into space? How are the mass and weight of the satellite affected as the satellite moves away from the surface of Earth? So if it moves away from the surface of Earth, the gravitational field strength of the Earth will decrease, right? Which is why its weight will be affected. But remember, mass always remains constant. Why does mass remain constant? But this is a universal rule that never. This is a key rule. This is very important. Why? Because mass always remains constant. So whenever they're saying that the mass decreases, this is wrong. The mass increases, this is wrong. Why? Because mass never changes. Now you have two options left, right? A and D, right? Now, both the mass and weight are unaffected. This is wrong. The weight will be affected. Why? Because the formula of weight is W is equals to mg. So if G is affected, the weight will be affected, right? So this can't be our option. So the only right option is the mass is unaffected and the weight decreases, because the gravitational, if G decreases, the product of this will decrease, which will result in weight decreasing. Hence D is our right answer. I'm sorry. Okay. uh, just went a little bit here. I'm sorry. Okay, question number 7. air is trapped in a cylinder by a piston. The piston is moved inwards so that the volume of the air reduces. So obviously you know that when we will move it inside, the volume will decrease. The piston is moved inwards so that the volume of the air reduces. Air with initial volume, air with final volume, right? Okay. So the density of the air in the syringe at the initial volume is this. So this is the density. What is the density of the air in the syringe at the final volume? So first of all, let's look at the formula of density. Density is mass per unit volume. Now, what are they telling us? They're telling us that air is trapped inside a cylinder by a piston. The piston is moved inward so that the volume of the air reduces. Okay. So air is trapped in a cylinder over here. The piston is so that the volume of air reduces. Okay. The density of the air in the syringe at the initial volume is this. Okay, what is the density of the at the syringe at the final volume? So one, two, three, four. So it moved over here, right? So it became so obviously if the volume if the volume decreased by half, if the volume was one, two, if the volume, guys, I'm sorry, I'm really thinking about it, that if the volume, which is one, two, three, four, and it became half, if the volume became half, right? So so if the volume became half, the density would become double, right? Will become two times. So now its new density will be 0.0012 times 2, which is 0.0012 times 2, which is 0.0024 gram per cm cube. Now, yeah, I faced a little difficulty in this, but there's no need to worry. I'll explain it to you again. That there were two air trapped in a cylinder. There are two cylinders over here, right? Each with pistons. The piston is moved inward so that the volume of air reduces. So the volume of air was reduced by half. If you can look over here, we have one, two, three, and four. So it was at four over here, and then it moved three and two. So which means that the volume became half. Now the final volume is now half of the initial volume, right? So if the volume becomes half, the density will double. Why? Because density is mass upon volume. If the volume decreases by half, the density will become two times. So I just multiplied the initial density by 2 to get the new density, which is 0.024 gram per cm cube. Okay, now question number 8. Some forces are applied at different distances from the pivot. Which diagram shows the force that produces the largest moment about the pivot? So first of all, let's look at what the formula of moment is. So moment is represented by a stylish P, right? Torque or moment is the same thing. So torque or moment is force into perpendicular distance. This distance is always from the pivot, and it is always perpendicular, and it is always in meters, right? So let's look over here what the moment is. So the force is 50 newton and the distance is 90, and we'll divide it by 100. Why? Because 1 meter as 100 centimeter, and we need distance in meter. Now let's look over here. So force into perpendicular distance, which is 2. So this will give us 60 newton meter of moment, right? And this force into perpendicular distance, which is 50 upon 100. I'll calculate it first. Let me write it, and this will be 18 times 3, right? So this will be 54 newton meter. This will be 40 newton meter, and this will be 45 newton meter. Now let's look which has the largest moment. So does 45 have the largest moment? No. 60, yes, it is one of the largest. No, no. So 60 is the largest, hence your answer will be B. The diagram shows a children wooden play tower. So this is the children wooden play tower, right? This is the tower over here, right? So which change to the tower makes it more stable? So a few rules of stability that I would like to talk to you about before solving this question. So the lower the center of mass, the lower the center of mass, the lower the center of mass, the more stable, right? So whenever you lower the center of the mass, the more stable, and whenever you make the base wider, whenever you so the 2 points, the lower the center of mass or center of gravity, the more stable, and and wider the base, wider the base, the more stable, right? So these are two key points, right? So if the base is wider, if the base of this tower is wider, right, so then it will be more stable. And if the center of mass is lowered, like if the center of mass was here, now it is lowered over here, which means this will be more stable than this, right? So now let's look at this. What change to the tower makes it more stable? Making the tower narrower? No. Why? Because wider the base, the more stable, not narrower. Making the tower taller. If you make the tower taller, the center of mass will rise. Hence, no. Raising the center of mass, no. I said lower the center of mass, lowering the center of mass. So this is the correct option. Now, question number 10. Where on the graph is the limit of proportionality for an elastic solid? So remember one key point. Whenever you get these types of question, always get the scale right, like I have over here, and draw. Put your scale over here like this, and and draw a straight line, right? Wait. So you see that, okay, sorry guys. So obviously I'm on my laptop, so I can't really show you correctly, but as you can see that the that this line is going straight over here, over here, over here, and it starts to bend over here somewhere, right? So whenever you put your scale and see where the line starts to bend, then that is your answer. So over here it starts to bend, which means that the limit of proportionality is reached over here. So which where on the graph is the limit of proportionality? So at P, right? So now question number 11. A weight of a weight of 2 Newton, a weight of 2 Newton is hung from a spring. The extension produced is 6 centimeter. So for 2 Newton, the extension is 6 centimeter. The 2 Newton weight is removed and a 8 Newton weight. 8 Newton is hung from the spring. The spring does not pass its limit of proportionality. What is the new extension? So this is pretty easy. This is just cross multiply, right? And why did, okay, now I'll ask you guys a question. Why did they say that the spring does not pass its limit of proportionality? Because when it does pass its limit of proportionality, force is not directly proportional to extension, which is why we would not be able to apply this ratio method, right? Now but since it was in the limit of proportionality, we can. So 2x is equals to 8 times 6, x is equals to 8 times 8 times 6 is 48 upon 2. 2 ones are 2, 2 twos are 4, and 2 fours are 8, right? So this is our answer, which is 24 centimeter, which is our new extension, not the new length of the spring, but the new extension. An object is placed at depth d below the surface of a liquid of density p. On which expression does the pressure on the object depend? So as you can see that pressure is rho, which is density, g, and h, right? So it depends on h. So over here h is the depth, so I can replace h by d, right? Right, on which expression does the pressure? So the pressure depends upon, obviously, density and the depth, because the gravitational field strength is obviously constant, which is 9.81. So it depends upon d and density, which is represented by this, which is called rho. So B is our correct answer, right? Because d plus p is not possible, this is not possible, this is not. This is simple formula. You have to look at the formula and just select the correct option. The diagram shows the dimension of a box of mass m and weight w at rest on a table. What is the pressure on the table due to the box? So the formula for pressure uh, is pressure is equals to force upon area. So the force over here will be the weight, and the area over here will be, y times z. It, because I'll explain it to you why. So let's suppose this is the rectangular block, right? This is the rectangular block, right? So I'm drawing this, I'm drawing the okay, let me draw it over here. So if you see, I'm drawing the lower surface, right? So for pressure, we will always select that surface that is in contact. So I won't do x times y times z. Why? Because only y times z. If you look at the lower surface, which I've drawn over here, this is the lower side, right? So this will be y and this will be z. So it will be y times z. Why? Because this lower side is in contact with this base, right? Not the whole surface, which is why I'll do y times z. Our correct answer will be option D, right? Now let's move on to the next question. Which graph shows the relationship between pressure and volume of a fixed mass of gas at constant temperature? Fairly easy. Pressure and volume which shows the relative pressure and volume of a fixed mass at constant temperature, right? So pressure and volume are inversely proportional, and the graph of inversely proportional is always a decreasing curve, hence B, right? Question 15. The work done by a force F on a of a body is calculated by multiplying F by a quantity Q. So you need to know the formula of work done. Work done is force into distance. I'm sorry, the connection got cut. So work done is force into distance or displacement, which is parallel to the force. Now look at what is Q. So the Q will be the distance traveled in the direction of force. Yes. Why? Because force and distance will always be parallel. So F and D. So hence A is the correct option. Now I've solved the first 15 question of this paper, and I'll solve the next. I'll see 25 questions in the next video. Till then, stay tuned. Allah Hafiz.